Okay, SLAA. The purpose of this video is to cover the notes from lesson 4, day 4, in case we run out of time talking about this material after the quiz in class. Okay? So with that being said, let's get started. What we're going to look at today is now what is the idea of an arithmetic series, right? Not a sequence. And we're going to talk about how to represent series with what's called sigma notation. So we've done the quiz on sequences, so we can cross through that. Hopefully that went well. And like I said before, we're going to introduce the idea of series, what they are, specifically talk about arithmetic series, and discuss sigma notation. All right. So just as a review, let's go back and look at this formula again that involves future value and present value. So the question is, what will investment of 45,000? Sorry, I don't know the unit of this symbol. What will that amount to after 21 months if the money earns 7.5% PA? This means per annum. Okay, so it's earning 7.5% annually, and it's compounded quarterly. So if we remember, right, the formula that we want to use for this is that the future value of an investment is equal to the present value of the investment times 1 plus the interest rate over 100 times K, where K is the number of times the rate's being compounded annually, or being paid annually, excuse me, times K N, and N is the number of years. So if we look at this information, we have 45,000, 21 months, 7.5% per annum, compounded quarterly. So that means we know that our present value is 45,000. Okay? The future value is the unknown that we're looking for. The annual interest rate is 7.5%, so I'm going to put that in at 7.5. K, the number of times that's being compounded or paid per year, to be more specific, right? The number of times that 7.5% is being broken up and paid per year is 4. And N is 21 months, which is 21 over 12 years. All right? So it's a little bit tricky in terms of our numbers here. So if we go back and we plug it into our formula, we're going to get that the future value of this money is worth or is equal to 45,000 times 1 plus 0.075 over 4. Okay, so all I did here is I took 7.5 divided by 100 and got 0.075 and divided by 4. So that 7.5% is going to be cut in 4 equal parts, and it's going to be paid 4 times a year. So the number of times that's actually paid, that 7.5 over 4 is K, which is 4, times 21 over 12. Okay, so let's clean this up a little bit. So we know that the future value is equal to 45,000. Now I got to run this on my calculator. Give me a second to do that. So let's see here. 0.075 divided by 4 is 0.01875 plus 1. So this inside all becomes 1.01875. Okay, so really, this part, this is the quarterly interest rate. If you're getting 7.5% per year, you're getting 1.875% per quarter. And 4 times 21 over 12, well, the 4 and the 12 becomes 1 over 3, and 21 over 3 is 7. So what that means is that over 21 months, right? 21 months, we're going to get 7 quarterly payments. We're going to get 4 in the first year, and then we have 9 months left over, so that's 3 more quarters. Okay, so now if we run this on the calculator, right? 1.01875 raised to the 7th. Sorry guys, I gotta get a better calculator here. My phone calculator, which I should not be using, is not capable of doing exponential stuff. So I'm gonna open Photomath, which has actually a pretty good calculator. All right, so let's see if this works. What I'm gonna try and do is scan this on Photomath and see if it will do this arithmetic. So let's take a picture of that. And if Photomath is right, which I'm hoping it is because I'm not going to check it, this is equal to 51,249 point, if I round, 06 cents. Okay. So I know you guys can check that. I know you guys will let me know if something is not correct there, but that's the number I'm getting if we do the computations. All right. And most importantly, I think, is the method, right? I know we can do the arithmetic. So let's just finish this up. So that is our future value of the money. So it's gained over $6,000 in 21 months. Not too bad. Okay, this slide was just to check, see if there were homework questions on stuff like we did here. All right. And now finally, this is new stuff. Okay, so first of all, and let me make sure it's not covered down here. Yeah, okay, it is. But if we're looking at these three problems, right? They're all asking us to find sums. Okay, and they all have some kind of pattern. So the numbers between 1 and 10, add them together. Well, that's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, so 3, 6, 10, 15, 21, 28, 36, 45, 55. Hope that's right. Should be. 100 add them together. Well, I'm actually going to cheat. That value, right? So that value, 1 plus 2 plus 3 plus 4 plus all the way up to 100. That's going to be 101 times 50. Okay? And you might be saying, how the heck are you getting that? And we'll talk about that soon. But 101 times 50 is 50/50. 5,050. Okay? The numbers 1 and 1,000. And by the way, when we say numbers, we really should be a little bit more specific. We really mean integers, because otherwise there's a lot of numbers, a lot more numbers between 1 and 1,000 than just what we're adding. Okay, so we're really adding the integers. So this last problem is asking what's 1 plus 2 plus 3 plus all the way up to 1,000. And I'm saying that's going to equal 1,001 times 500. Now maybe, a couple of you are seeing the pattern here. Maybe. Okay. So if I run that on the calculator again, 1,001 times 500, this is 500, 500. So we have this similar pattern. How the heck is that happening? Okay. So all those three previous questions had us computing a series. Okay, and what a series is, very generally, right? A series is equal to the sum, so we're going to add, of terms of a sequence. That's it. All right. So if I go back to this previous slide, here, maybe this first one's the best because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That could be a sequence if we had commas in between, right? Because we said that the sequence is an ordered list of terms. All right. The minute we put a plus in there instead of a comma, now we're generating a series because we're taking these individual terms and we're adding them together. All right. In arithmetic, and there's a typo here, and the typo actually occurs two different ways. Yikes. So in arithmetic, all right, so we misspelled two letters there. Here we got better, we only misspelled one. An arithmetic series is the sum, right? The sum of the terms in an arithmetic sequence. All right? So let's take, for example, this series, this list of terms and that are added together. Let's look at it a different way. Okay? So rather than think of it as 1 plus 2 plus 3 plus ... plus, and I'm going to deliberately do it this way, 98 plus 99 plus 100. The point is we start at 1, we add, and we stop at 100, right? Well, we could really regroup those and say this is really equal to 1 plus 100 plus 2 plus 99 plus 3 plus 98. And maybe you guys are starting to see this pattern. So we're going to have these pairs of sums. The last pair will be 50 and 51. Okay? Now what you might notice is that all of these individual pairs add to 101. Right? So that was part of the two things that I multiplied together here. So 101, this is really for me knowing that, oh, that's 1 plus 100 and that's 2 plus 99. Where does this 50 come from? Well, if we look here, right, we've got 100 total terms, but that means there's 50 pairs. Okay? So in general, if we generalize it for an arithmetic, we can say that the sum of n terms is equal to n over 2 times u1 plus un. Okay, and in our case, in this formula, right, we could say that S100, the sum of the first 100 terms is equal to 100 over 2. That generates our 50. So this part generates our number of terms. Sorry about that. And then 1 plus 100, well, that generates the value of the sum of each pair, right? So this equals 50 times 101. Okay? So this, and when I say this, I should probably underscore it so you guys can see what I'm talking about, right? That is one of the first formulas, one of two that you'll have for sum of an arithmetic sequence. All right, so there it is. In a little bit, better notation, but here, right? N over 2, u1 plus un. Okay, now here's the thing. Sometimes we might not have the last term. And so what we can do, and you can see it written here, is that we know that from before that the nth term is equal to the first term plus the common difference times n minus 1. So if we make the substitution of this expression right in here, well, I've got u1 plus u1. That gives me 2u1. And then I have this stuff, which we've written there. Okay, so you actually have two formulas that will let you find the sum of an arithmetic series, provided you have different information, right? This one, if we don't know the common difference, but we know the first and the last term, the first and the end term, and we know the number of terms, this one works. If we know the number of terms and the first term and the common difference, but we don't know that last term, we want to use this one. Okay? Yeah, so those are the two new formulas that you'll use for all these arithmetic series problems. Okay, so a couple examples now. Find the sum of this series, right? And so we don't have commas. So these are terms of a sequence that are added up. And we want to find the sum of the first 20. So really, we want to find the sum of the first 20 terms in this sequence. We better be sure that it is arithmetic, right? And just to confirm that, yeah, it looks like we have the same pattern of adding 4 every time. Okay, so what do we know? We know that u1 is 3. We know the common difference is 4. And we know that n is 20. we don't know right away U20. Okay, so since we don't know the last term, I'm going to choose to use this formula. Okay, n over 2 times 2u sub 1 plus n minus 1d. All right, so I'm going to write that down here. So in this problem's context, this is equal to 20 over 2. I'll write this up here. S sub n is equal to n over 2 u sub 1 plus n minus 1d. Okay, so n over 2 in this case is 20 over 2. Now we need to take 2 times the first term. The first term, sorry again. The first term was 3, right? We denoted that there, so that's going to be what we write in substitution or in place of u sub 1. And then we're going to add to that 20 minus 1 times our common difference, which is 4. So this turns into 10 times 6 plus 19 times 4. Okay, 19 times 4 I believe is 76. That's 80 minus 4. So we get 10 times 6 plus 76, which is 82. So the total is 820. All right. There we go. Okay, another one. An arithmetic series has 7 terms. So just from reading that, we know that n is 7. The number of terms is 7. The first term is 5. Let me highlight this. The first term is 5, so that means that u sub 1 is 5. The last term is 53. Well, that means that u sub 7, because we know we have 7 terms, is 53. Find the sum. Okay, so here we want to find the sum of the first 7 terms of the arithmetic sequence. But, right, we don't want to use this formula because yes, we know this, yes, we know this, yes, we know this, but we don't know the common difference. Okay, so we want to use what I think is easier, this formula here. Number of terms over 2 times the sum of the first and the last. And again, the sum of the first and the last is going to be the same as the sum of each kind of matched up pair. Okay, so in this case, we've got that s sub 7 is equal to 7 over 2, because we have 7 terms. So this is a little bit weird. We actually have 3.5 pairs, right? Because we're going to have like u1 plus u7, right? We're going to have u2 plus u6. We're going to have u3 plus u5, and then we're going to have u4 hanging out by itself. Okay, so we have 3.5 terms. And the sum of those pairs is going to be 5 plus 53, right? So this becomes 7 over 2 times 58. Okay, 2 and 58, that's going to cancel as 1 and 29. And you know what? I don't want to do, yeah, sure, let's do that. 29 times 7 is, 63. So I put a 3 there, put a 6 up top. 7 times 2 is 14, plus 6 is 20. So this is 203. Okay, let's see, what do we have left? So we have 1, and then introduction to 6 notation. Okay, so we have a good amount of stuff left, but we'll get through it quickly. Okay, we'll level up in terms of difficulty. 3 consecutive terms of an arithmetic sequence have a sum of 12 and a product of 80. Find the terms. Wow. Okay, so maybe we should just write this out generally first. So 3 consecutive terms. So I'm going to let the first term be u sub n. Now, if we know their arithmetic, my next term will be u sub n plus d. Okay, and then my third term will be u sub n plus 2d. And the reason I'm doing this is because I want to limit my variables. So right now I just have, one variable, un, and the second variable is 2d. And the reason I'm only trying to have 2 variables is because we have only 2 real equations we can write. Okay? So we know that they sum to 12, so that means if we just add these all together, right, we can say that one equation is that un plus d plus, and let me use correct language, not un, u sub n plus 2d. So the sum of those is 12. And if we clean this up a little bit, we have 3 UNs and we have 3D. And then if we divide everything by 3, we get something even more simplistic, that u sub n plus d is 4. Okay, that's an important equation. Second, well, the product is negative 80, so that means multiplying, right? So u sub n times u sub n plus d times u sub n plus 2d. That product of all 3 multiplied together is equal to negative 80. Okay, and what I'm going to do now is I'm going to do a substitution. I'm going to use a calculator. All right. So what I'm going to substitute in is I'm going to say, from this equation here, we know that u sub n is equal to 4 minus d. And I'm going to take that expression, I'm going to plug it in there, and there, and there. Okay, and if we do that, then we'll get, okay, here we go. 4 minus d times 4 minus d plus d. Oh, that's nice. These are going to cancel out. Might as well do that now. So these are canceled. And then the last one, we're going to get 4 minus d plus 2d. Okay, which really becomes, let's see, 4 minus d times 4 plus d, and that is equal to negative 80. Okay, so now I've got an equation with just one variable, d, here and here. So what I would do is I would take my calculator, I would n solve this, right? And I'll write the text that I would use. So I'm gonna say n solve, right? Open parentheses, 4 minus x times 4 plus x equals negative 80, and then I gotta put a comma and then an x, and I'm gonna just compute that. All right, I'm gonna run it right on the calculator. So give me a second to do that. Maybe you guys can pause the video or just leave it running and leave it running and see what you get when you do n solve, or solve it another way. All right, so let's n solve this thing. Menu, algebra, numerical solve, and we want in parentheses 4 minus x times 4 times 4 plus x. Repeating myself, right? Is equal to negative 80. You know what? I better make that a negative and not a minus, because otherwise it will not solve. Then I put my comma, put x, hit enter. I got 6. So okay, so sorry. So this gives by n solve that d is 6. All right. Then let's go with maybe a different color. Like let's go solve for u sub n, right? So if I plug in there, well, 4 minus 6 is negative 2. Which means that u sub n is negative 2. And therefore, now they say, find the term. So one term is negative 2. The next term, u sub n plus 1, is going to be negative 2 plus 6, which is 4. And then the last term, I'm going to run out of room here, so I'm not going to write u sub n plus 2. Well, maybe I can. Yeah, I should be kind of good about that, right? So let's circle this stuff. Let's move it so I get some more room. I can't really move it much, can I? Well, let's do this. That's okay. So u sub n plus 2 is going to be 10, because that's 4 plus 6. So, and that checks out, right? If we add 2 plus 4 plus 10, we get 12. If we multiply negative 2 plus 4 plus 10, we get negative 2 times 40, which is negative 80. All right. So, second new idea is the idea of sigma notation. Okay, this symbol, right? This is called a sigma. All right, and whenever you see it, it means add, right? Sum. So whenever we're trying to add a list of terms, right? If we don't want to write all the terms out, we can write this symbol, okay? And it's got a couple parts. This is the counter, so k is just an index variable, and the bottom number here is the number that you start with, and then the top number is the end that, or is the number that you end at, that you finish at. And wherever you see a k in the equation, you plug in 1, you write that result out, you plug in 2, you write that result out, etc. Okay? So, some basic properties. If you have the sum of terms add together, you can break up the sum, and you can just sum, okay, the first term, the sum of the second term. And the other thing that you can do is you can take a constant out. So if you have the sum of all these terms times a constant, it makes sense to take the constant out and then take the sum of the smaller result there. All right? Also, if you have the sum as k goes from 1 to n of a constant, meaning this doesn't change, that's just equal to that constant times n, because you're adding that constant together n times. All right, so let's look at what this stuff means. Okay, let's do some examples and then it will make more sense. All right, so we've got two examples. Okay, not too bad. So in this first one, right, this part, this tells me that I'm going to add 15 terms together. How do I know it's 15? Well, I know it's 15 because my first value, my low end, my first k value is 1. My upper k value is 15, and if I count 1, 2, 3, 4, 5, all the way to 15, I have 15 terms. Now, what's a little bit confusing, I think, is how do you get the individual terms? So I'm going to call these, you know, our normal convention, U1, U2, U sub 2, excuse me, U sub 1, U sub 2, U sub 3. All right, and let's see what we get. So to get U sub 1, that corresponds to k equals 1. So in the formula, wherever I see k, I'm going to plug in 1. Okay, so U sub 1 is just 1 minus 50, which is negative 49. Okay, U sub 2, well now k is 2, so I'm going to plug in, wherever I see a k, I'm going to plug in a 2. That's 2 minus 50. So that's 2 minus 50, which is negative 48. Okay, U sub 3, now plug in this formula 3 for k. Well, that's 3 minus 50, which is negative 47. So I think by now, hopefully we can see a pattern. I'm trying to rush, sorry guys. 3 minus 50, okay, that's negative 47. So this is an arithmetic sequence, because every time, right? Every time here, to get the next term, we're adding 1. Okay, so I'm going to go to our shortcut. So I want to sum the first 15 terms, and I know that that's going to equal 15 over 2. And now I know, right, that U1 is negative 49, and the common difference is 1. So this is going to be 2 times negative 49 plus 15 minus 1 times 1. Okay? Remember, this part is n minus 1 times your common difference. So this is going to equal, I'm going to leave it like this for now. 15 over 2 times negative 98 plus 14, which is 15 over 2. Negative 98 plus 14, I believe, is negative 84. Okay, now these will drop. That's going to be a 1. That's going to be a negative 42. I still need a calculator. Okay, 15 times negative 42 is, let's see, 15 times negative 42 is negative 630. All right, so that's our answer. Okay, so without really knowing it, this notation says add up an arithmetic sequence starting at -49 with a common difference of 1 and add up the first 15 terms. How do we know that? Because our top number, which is our n value, is at 15. So, you know, we stop this progression of terms at u sub 15. Okay, let's do the same thing here and let's look for a pattern. Okay? So, I'm going to start with, again, just writing out the first few terms. So u sub 1, well, that's 3 times 1 minus 13, which is -10. Great. U sub 2, well, that's 3 times 2 minus 13, so that's 6 minus 13, that's -7. U sub 3, well, that's 3 times 3 minus 13, which is 9 minus 13, which is -4. Okay, so now I see the pattern again, right? Every time we're adding 3. So now I'm going to use this same formula, but instead of 15, I got 35, right? This is going to be a 35. My first term is not -49 anymore, it's -10. N minus 1 is not 15 minus 1, it's 35 minus 1. And my common difference is not 1, it's 3. Okay, but it's the exact same formula that we're using. So S, the sum of the first 35 terms, is equal to 35 over 2 times 2 times u1, which is -10, plus, now I'm just going to cheat and say 35 minus 1 is 34, and our common difference is 3. Okay, so what do we get here? 35 over 2 times -20 plus, geez, that's 90 plus 12, so that's 102. And that's 35 over 2 times 82. Again, we get some canceling. 2 and 82 is 1 and 41. So 35 times 41 is, let's see what that is. 35 times 41 is 1435. Wow, okay, much bigger number. 1435. Okay, finally, that's it, guys. Oh, last thing. And this will be on the filled in notes. And this is also, I believe, on the unit plan, but why not correct it if we're here? This homework is not right. We changed the homework, okay? So instead of these, okay, you're gonna do 1AB, 2A, that's an A, and 3. And instead of these, same section, same page number, right? You're gonna do 2A, 3C, and 5, 6, and 7. Okay, so guys, hopefully that was helpful. I will stop the video now, and like I said, this is in replacement of what we normally do in class because we might be crunched for time.